Well, good morning, Precalculus. This is Lesson 7. I hope you're having an awesome day. This objective for today is understanding related angles and signs of trig functions on the coordinate plane. So before we get started with what related angles are, let's first of all talk about angles and their uniqueness. This is a notation for vectors. If you haven't seen that before, this is talking about a vector with length 5 and an angle of 30. Length 5, angle of 390, and length 5 with an angle of 750. So as you can see, I've actually drawn all three of these angles right here on this coordinate plane. Notice the length of that is 5 units, and the black one lies right here. I drew that one first, and then it just kind of goes from here up to there, 30 degrees. The red one also lies right there, kind of goes a full circle, and then up to there, because notice it's 360 plus 30. And then the blue one does 2 full circles and then up to there. Again, the same idea as that. So notice angles are not unique. There's actually infinitely many ways you could talk about this single vector. And just a reminder about vectors, when we're talking about a positive angle, it moves in the counterclockwise direction, whereas if we're talking about a negative angle, it moves in the clockwise direction. So now let's talk about this vector right here, vector of length 12 with an angle of 135. So notice right here, this length is going to be 12 and it's going to be off the positive x-axis 135 degrees. Now if you notice, 180 minus 135 is going to give you that 45 degrees. And this is what we call the related angle. We'll talk about that more in a second. But just think about this here for a second. If I make a triangle here, call this length A and this length B, sine of 45 is going to be A over 12, opposite over hypotenuse. Cosine is going to be B over 12, adjacent over hypotenuse. And then you could solve those simply by multiplying both sides by 12, and you get A is equal to 12 times sine of 45, or B is equal to 12 times cosine of 45. That's 12 over 1 times the square root of 2 over 2. Those are the same, so that's 6 times the square root of 2, which is approximately that 8.48. I'd probably want to stick with that 6 square roots of 2. But I guess simply spoken, related angles are positive, acute, and they're between the terminal side and the x-axis. So notice this angle here is positive, it's 45 degrees. It's between the terminal side and the x-axis. Okay. Now, what I guess you need to kind of remember or think about here is this length A is going to be a positive length, whereas this length B is going to be a negative length in our coordinate plane because it's moving, it's on the negative x-axis. So that's why it's going to need to be negative. So let's just practice real quick finding some related angles. Let's find the related angle of 100. Well, I've just drawn that angle of 100 here. It's a little bit past, 10 degrees past the vertical y-axis. So we just need to find what this angle is right over here. So I can say 180 minus the 100, and we would get 80. This angle over here would be 80 degrees. So that would be my related angle. Part B is 300 degrees. I've drawn that. This right here is at 270, so it'd be another 30 degrees here. But remember, my related angle is off the x-axis. So how far is it from here to here? Well, that angle is actually 60 degrees. If you want to talk about finding that, you would say 360. That's how far it is to here. Minus the 300 that you already have. That'd give you the 60 degrees. The next one is 210 degrees. I've drawn that. Again, this is at negative x-axis is there at 180. So this is 210. So you would just say, in this case, you'd say 210 minus the 180, and then you'd end up with 30 degrees. So then that angle right there is 30 degrees. And then in this case, D, notice it is 60 degrees, and it's right here approximately. And notice this one is positive and acute, and it's between the terminal side and that. So in this case, the related angle is just simply 60 degrees. So it's kind of different scenarios, one falling in the first quadrant, one falling, I guess I don't have one falling in second. Yeah, I do. Second, third, and fourth. Kind of different scenarios on how you can find those. I think you should be able to figure that out. Now, the next thing I want to talk about is think about a triangle drawn here. And we're just going to pretend that the radius is 1. We'll talk about the unit circle later if you don't already know about that. We're going to say this angle is theta. Now, there's a point at the end of this, x comma y, right? X comma y. X is how far it is off the x-axis, which could be 0, right, if this point was right up here. It could swing up there, and the x could be 0. And the y is how far it is off the x-axis, which again could be 0. Maybe if it swung down this way, then the y would be 0. But this would vary between 0 and 1 and negative 1. I guess between negative 1 and 1 for both of those values. But just think about this length here is x, and this length here is y. And this, again, we're calling that to be 1. So if we're talking about sine of theta, sine is opposite, which is the y over hypotenuse, y over 1, which would just be y. Cosine would be adjacent over hypotenuse, which would be x over 1, or just x. And tangent would be the ratio of the y length over the x length, y over x. So now if we're thinking about the sine of these trigonometric functions in each quadrant, we can just think about the sine of the x and the y coordinates, which we already know. We've learned that back in like preschool or something, I don't know, a while ago. So now let's just think about what would those sines be. Well, the value of sine over here, that's where I'm talking, the value of sine is going to be the value of y, which is just simply positive. So it's going to be positive. The value of cosine is the value of x, which is also positive in this quadrant. And the value of tangent is going to be y over x, which is positive over positive, so this is going to be positive. As I move across the line, sine is the y value, so it's going to be positive. Cosine is the x value, so it's going to be negative. And tangent is going to be the y value divided by the x value, which is going to be a positive or negative, which is going to come out to be negative. Into the third quadrant, sine is the y, so negative. Cosine is the x, so negative. And tangent is the division of those two, so negative over negative makes it positive. And then fourth quadrant, sine is going to be negative, cosine is going to be positive, and tangent is going to be negative. All right, so now all that to do this, let's try a couple examples of this. This is example 7b2. It says, evaluate -2 cosine of -150. In the right-hand corner over here, I've drawn our special right triangles, which you should have memorized and or in your quick reference that you can remember, but here we go. So I've just drawn this angle of -150. -150 means I'm going to move in the clockwise direction. Over here, I found its reference angle, which is 30. And since I'm wanting cosine, I'm going to come over here to 30 degrees. Cosine is adjacent over hypotenuse, so it's the square root of 3 over 2. So what we're going to do is we're going to just say this is -2. This cosine of -150 is actually going to be square root of 3 over 2. But since I'm in that third quadrant, cosine is my x value, and so it's going to be negative. So then all I need to do now is evaluate. Negative times negative makes this positive, so it's just going to be the square root of 3. Okay, here's one similar to example 7b3. It says 9/4 times tangent of -210 degrees. So I've drawn this negative 210. It's going to come, again, the clockwise direction over here. I found my reference angle to be 30 degrees. So I'm looking for a tangent of 30. Again, I'm going to come up here. Tangent is equal to opposite over adjacent. 1 over 1 square root of 3. I was going to say 1/3. So I have 9/4 times 1 over the square root of 3. And then in the second quadrant, this is again going to be negative because tangent is the ratio of y over x. Y is positive, x is negative. So this is going to be what the value of this tangent of negative 210 is going to be. Now we just need to evaluate and simplify, of course. Let's multiply this in here by the square root of 3 over the square root of 3. It's going to give me 9/4 times the negative square root of 3 over 3. My 3 goes into that 1 time, 3 goes into that 3 times. So this is going to be negative 3 square roots of 3 over 4. Alright, good luck. I hope you understood. If not, feel free to watch it again or ask questions. Your homework is page 68, 7 through 15 all, and then 6 more of your choice. Good luck.